All right, this is section 1-4, measuring angles. Okay, so a quick review of vocabulary. We're going to write true or false. All right, number one, ray AB names a ray with endpoints AB. That is false. Remember, a ray only has one endpoint. Two, you name a ray by its endpoint and another point on the ray. Well, that's true. All right, so new vocabulary word, angle. Other word forms are angular, angle, or angled. The definition of an angle is formed by two rays with the same endpoint. So here are some examples of angles. Name the rays that form each angle. So in number 3, we have ray BA, and we have ray BC. In this one, we have ray AB, and we have ray AC. Okay. So key note here, definition. An angle is formed by two rays with the same endpoint. The rays are the sides of the angle, and the endpoint is called the vertex. So back up to here, or here. This right here is the vertex, which is the endpoint of both of the rays. Each ray makes up a side. So we have the vertex, and we have a side, and we have a side. You can name an angle by its vertex. So this is angle A, we could call this. Okay, a point on each ray and the vertex, okay, or a number. So we may call this angle 1, and we can call this angle BAC. Notice how the vertex is in the middle. All right, next page. So use the diagram in the take note on this previous page here to name each part of the angle. So the vertex of that previous angle was at vertex A. All right, the 2 points that were not the vertices, or the vertex, was B and C. So the sides were AB, ray AB, and ray AC. We can name it by calling it angle A by its vertex, by angle BAC, or by angle 1. Also, we could have called this angle CAB if we wanted to. So let's try this again. What are two other names for KML? So cross out the ray that is not part of KML. That's going to be ray MJ is not part of this angle. So circle possible names. Well, we could name it by a number, angle 2. We could name it by the reverse LMK. And I think that's going to be it. All right. So let's do some definitions, more definitions. So we first define an acute angle. An acute angle is an angle between 0 and 90 degrees. Okay. And we can draw it because it looks something like this. A right angle is any angle that is exactly equal to 90 degrees, and it's going to look something like this. And we usually indicate a right angle with a little box here to indicate it's a right angle. An obtuse angle is an angle between 90 degrees and 180 degrees, and it might look something like this. Okay, and a straight angle, by definition, is equal to 180 degrees, so it looks like a straight line with the vertex in the middle. Okay. So using this diagram, ABC, so ABC is 70 degrees, and BFE is 90 degrees. Describe each angle as acute, right, obtuse, or straight. So angle ABC. ABC is 70 degrees, so it is acute. Okay. CBD is the other side of this. So in order to find that, we do 180 degrees minus 70 degrees, and that is how we get 110 degrees. That's greater than 90, so this is obtuse. All right, CFG. So CFG is, of course, the other side here. So again, we could do 180 degrees because it's a straight angle, minus 90 degrees. That's what makes up the other part, and we get 90 degrees. So this is a right angle because it equals 90 degrees. And then CFG H, excuse me, is a straight line. So this is a straight angle. And it equals 180 degrees. Okay. Another way we can measure angles here is using a protractor. So here's a picture of a protractor, and let's classify the angles. So LKH. LKH is right here, and it looks to measure approximately 45 degrees, or 35 degrees, yeah, 35 degrees. So therefore, this is an acute angle. HKN goes straight across, so it's 180 degrees. It's a straight angle. And MKH looks to be about 145 degrees. So that is an obtuse angle. And that's how you would use a protractor to measure angles as well. Okay, so using congruent angles. So we're going to use the photo to the right. We know ABC, so ABC is 49 degrees. Let's label that. What is DEF? DEF, notice this little mark here is the same. So we call that 49 degrees also. That mark indicates congruent angles. So ABC has one angle mark. The other angle with the same number of marks is angle DEF. Underline the correct word to complete the sentence. The measure of ABC and the measure of angle in exercise 18 are equal. Therefore, measure of angle DEF is equal to 49 degrees. All right, next one, postulate 1-8, angle addition postulate. If point B is on the interior of angle AOC, then measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So this is actually very similar to our segment addition postulate. So what it says again is that the whole is equal to the sum of its parts. So we're going to draw angle ABT with point L on the interior and then two additional angles. So angle A, B has to be the vertex, T. Here is point L on the interior, and we're going to draw an angle that goes through it. And those are my two angles. Okay. So complete the statement. Measure of angle ABL plus measure of angle LBT equals the whole measure of angle ABT. Okay, so how can we use that in a problem? All right, so here it is. Here's the whole problem worked out. We're going to write each step. So the measure of angle DEF equals 180 degrees. How do I know that? Because a straight angle measures 180 degrees. Okay, now measure of angle DEC plus the measure of angle CEF must also equal 180 degrees. So basically what we did there was we added. So the whole equals the sum of its parts. This is called the angle addition postulate. Okay. Now, next thing we're going to do is substitute the actual measurements for each of these angle names. So this is called the substitution property. Okay, now we're going to combine like terms. So this is called simplify. So 11x plus 2x is 13x. Negative 12 plus 10 is negative 2. Now I'm going to add 2 to both sides. And then finally divide by 13, and that's how I get my answer. Okay, 24. Use the value of x to find the measurement. So 11x minus 12 is equal to 11 times 14, what we just found, minus 12. So that's going to give me, I think, 154 minus 12, which is 142. So measure of angle CEF is equal to 2x plus 10, which equals 2 times 14 plus 10, which equals 28, plus 10, which equals 38. Okay, so lesson check. If the measure of angle ABD in the figure is 85 degrees, so ABD is 85 degrees, the whole thing is 85 degrees. Write an expression that represents ABC. ABC. Okay, so measure of angle ABC plus CDB equals ABD, angle division postulate. So let's substitute. What is CBD in my picture? CBD is X, ABD is 85. I'm going to subtract what from both sides? I think I'm going to subtract X from both sides. All right. So simplifying, I have 85 minus X is my expression. So this is an expression for angle ABC. All right, and that is section 1.4.